Okay, this is chapter 3. We are going to describe data using numerical measures. And basically, this is going to be like, I will try to be fast here because this is the theoretical part. I'm going to do the applications or solving problems on Excel. So this video is going to be, I will try to make it as short as possible. As we said at the beginning, that the first step we did is collecting data. Hold on, what is this? So the first thing we did is collecting data. After that, we organize data, and we visualize data in chapter 2. Today we will be doing what? We will be describing data using numerical measures, numbers. We are going to have 3 types of measurements, or actually 2 in some books. The first type of measurements is going to be the measures of center. Second type of measurements is going to be the measure of location. Third type of measures is going to be the measures of variation. Okay, measures of variation. These cannot be done individually. These, all of them give you the full picture about your data. It's not enough or sufficient to just find the measures of center, or just the measure of location, or the measure of variation. You have to look at the full picture. So to get the full picture, you have to get, for your data, you have to find all of these. At least you have to have the measure of center and the measure of variations. So that tells you how your data is built, how your data, what is the consistency of your data? Is it consistent, inconsistent, distracted? It's scattered, not scattered? Is it centered around the mean? Is not centered? Do you have outliers or something? Yes or no? So all of these must be done together. So the measures of centers. Just before I start, if you want to find your very simple example. If you'd like to know your performance in your classes in your semester, what do? You find the average, the mean. So why you find the mean? Or if you do exam, for example, suppose you are in a class and you are 70 students, and you are one of the students who get like 50% in that exam. Then the first thing comes to your mind that, oh, I did bad. It's not necessarily that you did bad, because you don't know the average yet of the class. If you ask the class, or if you ask your professor what is the average, and the average was too low, then you can say, oh, I did really pretty good. But if the average was high, maybe you can argue that, oh, I did bad, right? So, we have to know some measurements, which is, in this case, you use the mean. The mean measure the center of your data. Maybe you'll be caring about what? Knowing the variation of the class. The variation of how your data is distracted or gathered around the mean. If the variation was high, so the class grades is kind of scattered. Otherwise, they are kind of gathered if the variation is low. So we're going to speak about this quickly here. So the outcomes is what? We have to compute the mean, median, mode, and weighted mean for the set of data. The goal is to describe data. We're going to construct box and whisker plot graph. All of these we're going to use Excel, by the way. It's going to be faster and easier. Also, we're going to compute range, interquartile, IQ range, IQR, variance, standard deviations. Again, we're going to use these measures to describe data. And I will keep the z-score to chapter 6 and talk about that one later. But we will be finding the coefficient of variation as well, right? And I may introduce the empirical rule today or in this lecture, or I'm going to leave it to chapter 6 as well. Graphs are important, charts are important, but still we need more. This gives you a visual tool, but we need measures, numerical measures, center and variations. 2 measures are important just to describe your data. We have 2 important terms we have to know. The first term we call it parameter or parameter. The second one we call it statistic. What you have to know about these 2 things, the parametric or the parameter is a measure that's computed from the population. It's easy to make connections between P and P. However, the statistic is a measure computed from a sample. Okay, sample. Statistics is a measure from a sample. Parameter is a measure from a statistic. Why we care about 2 types of measurements? Give them names, because usually we do not have access to the whole population. It's easier to access a sample, small sample. So when I ask you to calculate the mean of the sample, you have to tell me that, oh, this is the mean of the sample, not the mean of the population. So in this case, we're going to call it, for example, when we talk about the mean, we're going to call it x bar. This is the mean of the sample. When you see x bar means the mean of the sample. However, the mean of the population, we usually call it mu, the Greek letter mu. So all of the measurements, mainly of the population, they take a Greek character, mu, sigma, delta, and so on. But for the samples, no, actually, they take usually a Roman character. Okay. The population mean, which is parameter, is the average of data. So to calculate the population mean, we just add the data, we divide by the total number of data. So this is a mu, which is the population mean. What is capital N is the population size. What is xi? Is the individual values. It's the observations. If you add all of the observations, you divide them by the n, you get the population mean. For the sample mean, we call it statistics, which is x bar. Again, you add the whole value, and you divide them by the number of the sample size. What is the sample size? It's the same formula. Here we divide by the sample size, the other one we divide by the whole population. But both of them we add the values together. We get the summation of the values. Okay, and I will be explaining all of these in the video. The median is another measure. We use it to find the center value. There's a difference between the mean and the median. The median is the middle value after rearranging data in order. If you put your data in order from smallest to largest, then you can find the median. Why do we find the median? We can explain this later. Again, the population median, we call it mu tilde, something like this. And the sample median, we call it m sub d, probably, in some of the books. So the median basically is the center of the data after ordering them, and it divides the data into two equal parts, two halves. This is the numeric way of finding the median, sorry. It's just you put them in order, then the sample in order, then you take the sample, you divide by half, then it tells you the location of the median. The location is going to be in that position. When you do this operation, you will be getting 1 out of 2 numbers. Maybe the answer is going to be integer or it's going to be non-integer. If n, for example, is 10, suppose n is 10, then half times 10 is 5. So the median is going to be number 5 and 6 together. The observation number 5 and 6, you add them, you divide them by 2. The observations number 5 and 6 after you ordering them. If n is, for example, 11, then half times 11 is 5.5. So the position of your median is going to be number 6. Okay, you just round it up. We're going to do this in Excel as well. Your data, when we did the graphical representation of the data, sometimes the data can be symmetric data. Symmetric data is going to be something like this. This is symmetric. This is the most preferred kind of data. If you graph your data using histogram and you find something almost symmetrically, like something like this, then this is a really good data. And in this case, the mean is equal to the median. The other two cases, when you have skewed data, the skewed data when the data are not symmetric, so you have two types of skewness. The first one is the right skewed data, and the other one is the left skewed data. If you have left skewed data, the mean is always less than the median. If you have right skewed data, the mean is always greater than the median. This is right skewed, left skewed. The third type of measurements that tells you the center is the mode. The mode tells you the most occurring value, the value that occurs the most. This is the mode, so which is the value in the data that occurs most frequently. Sometimes we have more than one mode, that's fine. We have 2 modes or 3, that's okay. Other types of measurements of locations, sometimes we have to do the weighted mean, especially when you have the values, they have different weights. For example, I'm going to give an example about your GPA, your what do you call it? GPA, semester GPA, let's say. Sometimes you take in classes of 3 credit hours, sometimes you take classes of 2 credit hours, classes of 4 credit hours. So they have different weights. That's why you cannot, for example, if you have 4 classes or 3 classes and then you get 19 each, let's say 90 and 80 and 70. But this one, let's say it's 2 credit hours, this one 4, this one 3. So these do not have equal weights. That's why we have to calculate that weighted mean in this case. And I'm going to explain in Excel how to do this. So the weighted mean is one of the things that we have to consider when we find the measure of center. Percentiles is one of the things that we do when we would like to know the location of things. So the pth percentile in a data array is a value that divides the data set into 2 parts. The lower segment contains at least p%, the upper contains 100 minus p%. The 50th percentile is the median, the one in the middle. 50th percentile means what? 50th percentile means that this value gives you the middle value. Or in other words, 50% of the data are less than this value. This is the meaning of the 50th percentile. A special case of the percentiles, we call it quartiles. So we divided the data into 4 equal parts. Q1, first quartile, Q2, second quartile, Q3, third quartile. So Q1, so from this is the first part, Q1, Q2, and Q3, right? Then you have the maximum and the minimum data. The max and the minimum. So we have quarters kind of, right? So 25% less than this, so let's put it that way. So this is Q1, 25% less than this data. This is Q2, kind of. 50% of the data less than that one. This is Q3, 75% of the data less than this one, and here is the maximum, so 100% is going to be less than this. Maybe we can have some outliers, we can speak about this. So the weighted mean, this is a formula. We multiply the weight times the values, then we add all of them. Then after that, we divide by the weights, total number of weights. This is for mu population, this is for the sample x bar. Percentiles, again, we have a formula that gives you the location of the percentile, and we are going to show an example again in Excel. We can use this formula. Quartiles, again, we talked about the quartiles. We have 25%, first quartile, second quartile, and third quartile. Right? Second quartile, 50th percentile, and which is the same as the mean. Quartiles are important measures to create a plot. We call it box and whisker plot. So now I'm going to stop an example here because it's important. The box contains of 3 or 5 main things, basically. The box width, which ranges from first quartile and third quartile, and there's a vertical line in the middle of the box, or somewhere in the box, placed somewhere in the box, represent the median. And we have limits. The limits. These are the difference between Q1 and Q3, below Q1 and above Q3, 1.5 times the difference, basically. And the whiskers outside extend to the left to the lowest value within the limits, and to the right to the highest value within the limits. Example, let me take an example here. Construct a box and whisker plot. We have a data now. So what we have to do is finding Q1. How to find Q1? First of all, we just look at P over 100 times N. What is P first quartile? P is 25%. So I'm going to plug in 25% here, 25. What is N? How many data set do we have? We have 45. So you multiply these, you get 11.25, right? So Q1 is going to be in the position, the data or the observation that is going to be on that location, location 12. The value that is located in observation 12 is 250 miles. Now let's find Q2. Q2 is in the median, which is 50%. So P is going to be 50. So 50 over 100 times 45, which is the sample size. So you get 22.5. 22.5, that means you can just round it up to get the 23. So you're going to look at the data that is positioned in the 23. So it's going to be 259 miles. After that, we find the 30 quartile, which is again, 30 quartiles means 75%. 75 over 100 times 45, which is 33.75. This guy, you round it up. So the data set, or the observation that is located in the 34 position is going to be your data, which is in this case 266. Someone's going to tell me, how do you know the location? Yeah, we have to order them. We have to write these in order. Again, we're going to do an example in order, from the smallest to largest. So after having these, now we can start doing the box. We have Q1, we have Q3. This is Q1, this is a Q3 here. Then we're going to locate the middle, which is a Q2, the median, which is somewhere here. This is the median, Q2. After that, we're going to calculate the lower limit and the upper limit. What is the upper limit and lower limit? We call them interquartile range, by the way, which is Q1 minus this formula. We just plug in numbers, we get this one. Plug in these numbers, we get that one to get the upper limit. And we put them outside. And any value in the data set greater than this number or less than this number, they're going to be outliers. Outliers. So we're going to see, do we have outliers within the data? Do we have something greater than 290 or less than 226? We're going to place them out. Okay. So these are the two measures that I would like to talk about right now. I'm going to talk about the measures of variation in another video. Now you can look at the Excel and how the examples we can do in Excel.